Morning all. Today we will be talking about advanced seismic attributes. Now in advanced seismic attributes, what is important to understand that there are a couple of geometric seismic attributes which need to be known to the interpreter in order to give meaningful understanding to the attribute analysis in hydrocarbon evaluation. Geometric attributes started quite early in the last part of the 1990 when geometric seismic attributes were derived as calculation of the 3D seismic reflection data. In the part 3, I have told you about how the 3D seismic data need to be acquired and what is the importance of 3D seismic data, because the visualization can be in the three-dimensional sense. Now, the geometric seismic attributes are used to extract geological features such as faults, stratigraphy, channels, and rock properties from seismic data. There are a couple of attributes which we will talk about today, which are deep attribute, azimuth attribute, deep azimuth combination, curvature, roughness, age map, illumination map, coherence time slice, etc. Now, the first slide here shows the deep map used as quality control of automatic tracker performance. The very straight high deep pseudo faults are tracking bias. Deep magnitude and azimuths shows the deviation of a seismic reflector from a horizontal plane. Deep azimuth is the direction relative to the north that plane is dipping, where values range from 0 to 360 degree. Specifically, deep magnitude and azimuth are calculated from apparent dips of inlines and crosslines. And it is very useful to understand the subsurface features, and in this case, we'll show you a couple of examples for the same. In this diagram, we see the azimuth map from Venezuela. The red arrows indicate anomalies which conform well to existing fault patterns and are the probable additional faulting. So the complex faultings which we see, or the faultings where there are a lot of antithetic and synthetic fault and a fault patterns developed into a flower structure, maybe a positive flower structure or a negative flower structure, the azimuth map is an important attribute to be derived out from the 3D seismic reflection. There is another map here showing the dip for Nigeria. It consists of many faults, and arrow indicates that one fault visible on dip map but not on azimuth map. So the suggestion is that we should use both deep and azimuth in combination in order to get a better picture both in the inline and in the crossline. We'll take another example here where the azimuth map from Nigeria is once again presented, and in this case the arrows indicates one fault visible in azimuth but not in deep. So what should we do? We should take deep azimuth combination map for both onshore and offshore. Here is an example of an offshore. The Netherlands azimuth is coded hue according to legend. Deep is coded to color density. The horizon is just above a salt dome, and we can see it is located in the southwest corner. Now, combination of deep and azimuth are useful for inlines and crosslines because the deep magnitude and azimuth are calculated from the apparent dips of inlines and crosslines. Map of azimuth is on the top. The curvature and roughness attribute for the same horizon is given below. Curvature and roughness are the derivatives of deep and azimuth and help to high flexure. Now, curvature is a seismic attribute that shows how a reflector is changing shape. Curvature is defined in 2D as a circle that is tangent to reflector Values of curvature range from negative to 0 to positive, where negative and positive curvature are concave up and concave down respectively. 3D curvature is defined as having two perpendicular circles tangent to the reflector. Curvature is used for fracture identification, whereas roughness or smoothness is an image processing technique on seismic data. It is used to map faults, fractures using the concept of razor-sharp edges, taken the thin fault likelihood attribute as the input. Here is a edge map from Argentina. Arcuate fault, about 7 km long, barely visible displacement on vertical sections has been brought out very nicely on the edge map. The edge maps are very important for understanding the reflector change in shape, and it shows discontinuity surfaces, fault and fractures, and also it is based on identification of nodes and vertices. However, the most important implementation of seismic attribute is the identification of channel, and we can see a channel in blue color at the left which is important to be mapped. The channel has two lobes, and that is what has been brought out very nicely in the lease area shown here from Argentina. Illumination display or shaded relief map on base reflection from a gas field in Netherlands. The direction of illumination is from the northwest. Note the graben just southeast of center, and it is important to understand from the relief that how the subsurface spatial distribution is and how it mimics the surface. It also helps us to understand that where are the faults. The faults has been clearly brought out. On the northern side we can see a scissor fault, whereas in the south we have a normal fault. Illumination attribute actually gives certain portion of the map in a illuminated more than the rest of the part of the map. Illumination is from one direction. It is a seismic meta attribute and helps in texture mapping. Relief is understood from this metadata. Here is another example of illumination display of horizon from Northwest Shelf, Australia. You are able to see the direction of illumination is from the northwest. The fault pattern is very clearly brought out by the dark blue color, and we can see that the fault actually isolate the map into two parts, one in the northwest and another in the southwest part. And the northeast, there is a fault which is shown in white, and the illumination is less there. The fault has been clearly brought out, which cuts the main fault, which is blue in color. So illumination is an important horizon attribute which is useful to understand the relief, to understand the texture, to understand the disruption, to understand the dissociation, and to understand the fault and fracture. Here is another illumination display of horizon from Northwest Shelf, Australia. The direction of illumination is from the northeast, and we can see a clear fault coming from the northeast to southwest, which is useful to map and to understand the subsurface feature which is present in the map. Now, the next slide talks about the coherence time slice. Coherence is a class of attribute that differentiate or similarities shown between neighboring waveform or traces. Trace study is very important, and we have talked in the previous lecture that the shape of the trace is also useful attribute for understanding how the neighboring trace is similar or dissimilar to the trace of study. Since seismic data is a result of seismic wavelet that is responding to the subsurface geology, difference in neighboring wavelet correspond to difference in the subsurface, and therefore coherence is useful for showing faults that have reflected displacement. Common algorithm for coherence include variance, semblance, and cross correlation. In this case, we can see that a fault pattern, which is the dominant fault, is from the northeast to southwest. There is a gas pocket which we can see in red, as we see from the coherence time slice, which is in the southeast direction. In the southwest direction. And we can also see small gas pockets which are there and tested by well drilling, which are shown by the orange color. This is a time slice at 1525 millisecond from Gulf of Mexico. For comparison with above figure, we can see the structural closure which is there on the left side of the map. The fault can be seen which dissects the field into two parts, one which is more on the northeast and trending towards the southwest, and we can see at the southeast part there is a nosing feature which has been brought out very clearly on the time slice. Now the coherent time slice at 1640 millisecond from North Sea, we can see the nosing feature once again, but the structural disposition of the four-way closure is not brought out clearly. The fault patterns has been found out and microfaults has been identified from the coherence time slice. Time slice at 1640 millisecond from North Sea also gives an understanding how the structural disposition here. We have mostly two color patterns which we can see. One is in black and one is in red, and these are very good fingerprints which shows how similar the seismic response is to the response at user defined location. Response is captured to find similar good reservoirs as encountered in certain wells. These are all stratigraphic type of feature or structural type of features which are identified based on the fingerprints, and fingerprint can be taken as a great attribute in order to understand the stratistructural features in a time slice or in a horizon slice. Now, another attribute which is of importance here is the Chimney Cube, which highlights vertical displacement or disturbances in the seismic data used in hydrocarbon migration path mapping and geohorizon interpretation. Onset of chimneys may indicate source rock, so we can see the nosing feature which is there in the southeast may be actually a depot center, which is the source, or the kitchen, which through the fault it is actually feeding into the structural closure which is seen on the eastern part of the map. And the most important thing is to detect DHIs associated with the low hydrocarbon saturation. It can predict oil versus gas phase reservoirs also. So in nutshell, what we have learned today is that geometric seismic attributes are derived calculation of 3D seismic reflection data. There are many types of geometric seismic attributes like deep azimuth combination, and we have seen that deep and azimuth study alone is not very useful. So deep and azimuth has to be combined. We have also seen the curvature and roughness, which is important to understand. We have seen example of age map and illumination map, and time slice and horizon slice superimposed with that attribute of coherence is important to understand and extract geological features such as fault stratigraphy channels and rock properties from seismic data. We also understood what is curvature. Curvature is a seismic attribute that shows how a reflector is changing shape. Curvature is defined in 2D as a circle that is tangent to reflector. We also understood what is roughness. Roughness or smoothness is an image processing technique on seismic data. It is used to map faults, fractures. It should be combined with another geometric attribute which is the age map which shows the discontinuity surfaces, faults and fracture. It is based on identification of nodes and vertices. Illumination is a 3D attribute which shows the certain portion of the map which has a higher relief or a texture based on illumination, and so illumination happens from one direction. Illumination is a seismic meta attribute. Then we learned that what is coherence. Coherence is also very important attribute to be understood. Coherence is a class of attribute that shows the difference or similarities between neighboring waveform or traces. Since seismic data is a result of seismic wavelet, this is responding to the subsurface geology. Two important aspects which has to be kept in mind is that the gas shadow zones, which can be seen from the Chimney cubes, the gas shadow zones can be understood from vertical seismic, can be understood from the inlines and crosslines. Also, we can prepare maps where there are gas shadow zones. The gas shadow zones has to be carefully understood because the shadow zone is difficult to be differentiated from shale. Shale also has shadow zones and gas also can give shadow zones. However, the Chimney cube, which is an attribute important to highlight vertical disturbance in seismic data, and also in a large scale within the cube, it helps in hydrocarbon migration pathway tracing and also geohazard interpretation. Recently, it has been added as a very important attribute in DHI, that is the direct hydrocarbon interpretation, direct hydrocarbon indicators associated with low hydrocarbon saturation. So, it is an attribute today used for predicting oil versus gas phase reservoir. Another important thing which we understood, that we should see the fingerprint in the seismic in the horizon slice and in the time slice. We should be very careful in understanding the similarity of seismic response to the response at a particular location, whether we identify from the fingerprints the barrier bar or there are tidal inlets incursion within the barrier bar, that is the chanions. The fingerprint should be understood, and the properties of the drilled well to a particular horizon of interest can be correlated to the neighboring well. Fingerprint attribute along with the Chimney cube is very useful to understand the gas locations, the gas pockets, and today both these are combined to understand the gas migrations also. In Cambay Basin, many wells has been drilled based on the chimney attribute and the fingerprints, and we have seen that appraisal wells and also sometimes the development wells has been put across based on purely stratigraphic traps that has been identified based on the attributes, and the attribute at a particular location is seen how it is having a correlation with a location away from the particular well where we have drilled it, and based on this pattern recognition, based on semblance, the next well is drilled. Yes, the geological risks or the probability of success calculation will be risky, especially from the trap and the cap point of view. So, there will be a probability of success which will be low for these two attributes, which will bring the probability of success for drilling to a lower extent. However, these are some of the useful techniques which are utilized today, which helps to understand attributes in more detailed way and its application in hydrocarbon delineation and exploitation. Thank you very much for listening to the part 4 of the seismic attributes. We will go to the next part in the next session of the video.